Welcome to a demonstration of the assembly and setup for membrane filtration using Neogen's filters and ampules. By the end of this video, you should be able to properly prepare your area, clean the manifold, and be able to set up the equipment for membrane filtration. A short self-check quiz follows the presentation. We encourage you to pause and review the video as needed prior to taking the quiz. Membrane filtration is used to separate any potential living microorganisms from a liquid sample through the use of a 0.45 micron filter and vacuum pressure. Correct assembly is essential to achieve the best results during filtration. First, always clean the filtering area. Be aware of and avoid any sources of contamination. This could be a vent that blows over your workspace or dust on a shelf above or next to your area. You can perform filtrations within a laminar flow hood as an additional precaution. That too should be cleaned thoroughly prior to filtering. If there's any buildup or debris in the manifold opening where the stopper sits, wipe it down with a paper towel. Then, add a disinfectant of 10% bleach, isopropanol, or other validated cleaning solution to each opening and allow it to sit for 30 seconds prior to opening the valves. Let the cleanser stay in the system briefly prior to rinsing it with sterile water. Always rinse your manifold to prevent any backflow of disinfectant into the system that could negate the results of a future test. Next, wipe down or replace dirty adapters or stoppers as necessary. If you add any disinfectants, remember to rinse them clean with sterile water. Prior to beginning the test, remove your ampules from the refrigerator to allow them sufficient time to reach room temperature. This takes approximately 30 minutes. Set your clean manifold in the center of your workspace. Use the filtration connectors to attach a minimum of 2 sidearm filtration flasks in tandem with the vacuum pump. Always use an additional sidearm flask to prevent water from getting into the vacuum pump. It's a good idea to use a piece of rubber tubing to direct the exhaust's airflow away from your work area. Insert the adapter-stopper combinations into the appropriate manifold areas and press down firmly. If either stopper or adapter pulls out during filtration, just reinsert it. This won't cause any issues. Finally, close the manifold's valves and check the vacuum pump to see how many psi, pounds per square inch of pressure, it's pulling within the system. For testing with Neogen filters, it must be set no higher than 15 psi. Higher pressures can result in the stretching or tearing of filter membranes. This can result in not capturing all bacteria present in a sample. Setup is complete. You can now begin filtering your samples. The testing procedure for membrane filtration with Neogen filters and ampules is covered by another video training presentation. If you have questions about proper assembly, Neogen has a dedicated technical service team specific to this product line available to assist you. Welcome to a demonstration of the membrane filtration testing procedure using Neogen filters and ampules. After viewing this video, you should be able to properly run and incubate your samples. A short self-check quiz follows the presentation. We encourage you to pause and review the video as needed prior to taking the quiz. Prior to beginning the test, remove your ampules from the refrigerator to allow them sufficient time to reach room temperature. This takes approximately 30 minutes. Begin by choosing either white or black Neogen filters, depending on your need. This would also be a good time to make sure they are labeled appropriately for the samples you are running. Ensure the equipment has been cleaned and set up properly. This should include checking to make sure the vacuum pressure is set to no higher than 15 psi. Holding the base only, use a twisting motion and gentle downward pressure to seat the Neogen filter on the adapter. Do not press down on the lid or the funnel, as this could make it difficult to separate monitor sections later. Next, remove the monitor cover from the Neogen filter and aseptically pour your sample onto the membrane. Immediately place the cover back onto the monitor to prevent contamination. Open the valve and apply vacuum pressure. Allow the entire sample to be drained from the monitor. Close the valve. An optional step, lift the cover and rinse the inside walls of the funnel with sterile buffer. Place the lid back on monitor. Open the valve to reapply the vacuum long enough to pull the additional buffer through the membrane. Close the valve. Break any residual vacuum pressure in the system by briefly lifting the Neogen filter from the adapter. You do not need to remove the adapter from the stopper, just from the monitor. Gently re-secure the Neogen filter into the adapter as before. Using your ampule of choice, lift the lid and firmly squeeze the ampule 2 to 3 times to cover the surface of the membrane and media. Here are a couple of tips to follow when dispensing media. Do not drip the media across the membrane, and do not touch the membrane with the ampule tip. Also, try to keep the ampule and your fingers out of the funnel area as much as possible, working just over the top of the monitor. When finished, replace the lid to prevent contamination. Open and close the valve quickly, just long enough to allow the vacuum pressure to draw the media into the pad beneath the membrane. Do not overfilter during this step. Immediately break any residual vacuum pressure remaining in the system by lifting the monitor from the adapter. Examine the monitor. There should not be liquid pooled on top of the membrane. When inspected from beneath, the pad should be moist, not oversaturated or dry. If you've performed this step correctly, you'll see a small pocket of air around the bottom port. Place the end cap on the bottom port of the monitor. Remove the funnel section by gently twisting the funnel apart from the base and lid. Appropriately discard the funnel section and quickly fit the lid onto the base to create a disposable petri dish with your sample. Taping small stacks of plates together or using a Tupperware container is a great way to keep multiple samples together. You can now incubate the Neogen filter petri dishes topside down at the temperature indicated for the media used with the filter. After placing your samples in the incubator, clean up your workspace and the manifold. Reference the Neogen filter assembly video for the exact procedure. After rinsing with sterile water, the equipment can be disassembled. Invert the manifold and place it on paper towel to air dry. Some manifolds can be autoclaved for sterility as well. Following incubation, count and record all results appropriate for your chosen media. Dispose of the plates in accordance with all applicable local, state, and federal regulations. The used monitors should be treated as biohazardous waste, since they have the ability to grow organisms, even if none are visible. If you have questions about this testing procedure, Neogen has a dedicated technical service team specific to this product line available to assist you. The following video demonstrates how to accurately count and report results obtained using Neogen's filter and Ampoule system. By the end of this presentation, you will be able to enumerate organisms, record your results, and account for any sample dilutions. A short self-check quiz follows the presentation. We encourage you to pause and review the video as needed prior to taking the quiz. After incubating the filter unit at the specified temperature for the recommended amount of time, remove the unit for counting. When testing using a non-selective medium to obtain a total plate count, all colonies that grow must be counted and reported. A total plate count is also referred to as standard plate count or total aerobic count. Non-selective media can differ in pH, which promotes the growth of different types of organisms. Use selective media when testing for a specific organism or type of organism, such as coliforms. In this case, count and report only colonies that exhibit characteristic traits specified for that medium. See the video on membrane filtration products for more information on which colonies to count for each type of selective media. After counting all colonies, results need to be properly reported. Membrane filtration results are typically reported as colony-forming units, CFU, per 100 milliliter of sample tested. This is easy if 100 milliliters was originally filtered. Example, there were 16 colonies on a total count membrane after incubation, and 100 milliliters of sample was filtered. This is reported as 16 CFU per 100 milliliters. At times, you may need to dilute your samples. This may be necessary if your samples have results that are too numerous to count, TNTC, or if you need to increase the filtration efficiency of your sample. Typically, when a sample is diluted, the dilution needs to be taken into account when reporting results. This can be done through a calculation that uses your final count and a dilution factor. The following example shows how to calculate a dilution factor, and then calculate your final result using the dilution factor. A sample is diluted 1 to 10. 10 milliliters of sample was added to 90 milliliters of sterile buffer and underwent membrane filtration. The requested specification amount was 100 milliliters. To find the dilution factor, divide the requested specification amount by the amount of sample actually filtered. 100 milliliters, requested specification amount, divided by 10 milliliters, amount actually filtered, gives a dilution factor of 10. To determine the reportable number of CFU per 100 milliliters, the number of counted CFU obtained from filtering should be multiplied by the dilution factor. If 2 CFU were recovered on the membrane from the diluted sample above, this would look like 2 CFU, the number of counted CFU, multiplied by dilution factor, 10 in this example, equals 20 CFU. This would be reported as 20 CFU per 100 milliliters. Example, 6 colonies are counted from a 1 to 5 dilution, 20 milliliters of sample into 80 milliliters of sterile buffer. What is the reportable CFU per 100 milliliters? Requested specification amount, 100 milliliters, divided by amount of sample actually filtered, 20 milliliters, equals a dilution factor of 5. The number of CFU counted, 6, multiplied by the dilution factor, 5, equals 30 CFU. Report as 30 CFU per 100 milliliters. A note of caution when using dilutions. Testing small amounts of sample in large amounts of sterile buffer, 1 to 50, 1 to 100, etc., is possible and might even be necessary. However, increased dilution makes ensuring a representative sampling more difficult. Here's an example of how plates can vary if a sample isn't homogeneous. To address this potential issue, it's best to mix the product prior to sampling to make sure the product is well homogenized. If using high dilutions, running 2 to 3 monitors per sample gives a better representative picture and provides a double check of sample homogeneity. Thank you for watching. Neogen has a dedicated technical service team specific to this product line that is available to assist you if you have questions regarding counting and reporting results, or accounting dilutions for membrane filtration using Neogen filters and ampules.